And we talked a little bit about life after solar with internships, but I'm sure that as a high school student, you're thinking about what's ahead of you and probably thinking about college. And so we brought a representative of the University of Texas at Arlington Department of Engineering over to talk to you a little bit about their program and what to do. So I invite you guys to present.
Okay, thank you. I guess I'm okay now, right?
Perfect.
Okay. All right. Well, I just got in on the tail end of Shannon's presentation there, but this is really exciting competition that you're working on, a fair amount of complexity and all of this too. Now you'll see under my name, maybe you'll see Diana. I'm clearly not Diana, right? So I'm actually an associate chair in the Department of Electrical Engineering. And I was former chair, Dr. Huffaker, who was planning to be here, couldn't be. So she asked me to talk just a little bit about the department and various things that we do in the department, many of which relate to what you're doing in the competition. We're excited to be a part of this competition as well in terms of like sponsoring events. And so let me see, I think I can share, right? So let me share a few slides. So at any rate, let's talk just a little bit about electrical engineering at UTA. It turns out that many of the things we talk about in electrical engineering or the capabilities we have relate very, very closely to many of the aspects of the projects you're working on with the cars here. And so I was going to go into a slideshow, but for some reason I don't seem to be able to do that. But that's okay. I guess you can see my slide here in the middle. So one of the things we like to point out about electrical engineering is there's a lot more to it than people sometimes think. Sometimes there's a concept out there some people have that it's just all about power, like conventional power lines, generation, distribution, and so forth. But it's really about much, much more than that. So we're talking about fun facts about electrical engineering and all the different interactions that a person will have with things that are at least partly designed by electrical engineers over a given day. And so I don't think you have to look too hard. Things you carry around with you that you're sitting at, like this laptop I'm presenting from, iPads and so on. Many things that have a significant contribution from electrical engineering, including the internet itself, various types of sensors. You hear people talk about Internet of Things and so forth. And, a small version of Internet of Things is something you might do in your home, but it's really kind of an emerging area that as the wireless communication capability picks up, for example, we move from 5G to 6G, there'll be a lot more of this kind of thing enabled. So electrical engineers work on components from a wide range of sizes. So you talk about the power grid as one example, clearly hundreds of kilometers long, to things on nanometer scale where you're dealing with nanotechnology, developing new types of photonic or electronic devices. And the power levels are also of, quite extreme, where you're talking about power in gigawatts down to, with these nano type devices, maybe picowatts. And so it's just, electrical engineering is in so many places. And like I said, in a lot of the things that you're working with here. And one of the things that people don't appreciate sometimes as much is like a lot of electrical engineers do quite a bit of programming as well. So programming is not all about like computer science. We do a lot of programming in terms of, defining the functionality of a system or trying to simulate what kinds of behaviors that we want to put into a system. So there's a lot of programming in electrical engineering as well. One of the things we like to point out, this is actually a video that was produced by someone that graduated from University of Wisconsin, I believe it is, actually in civil engineering, and he produces a lot of videos about careers and so forth. And one of the videos that we found quite interesting, where he was talking about electrical engineering, he described it as the #1 engineering discipline in which to work in 2021 and beyond. And what he did is he did a salary survey. I think it was the 2019 IEEE salary survey that was done, and found the jobs that a lot of that are done by electrical engineers and their pay scales. And what you see in the left-hand, lower left-hand column here, it indicates all the different types of jobs that electrical engineers have. And the top one in terms of pay, for example, is smartphone watch engineer. But you can go down the list, you know, energy and power is pretty close to the top, robotics and automation, but a lot of software development, machine learning, and so forth. The one that I work most with is electromagnetics. So we deal with, you know, using spacecraft to do sensing of the environment. There are just so many things in electrical engineering. And so one of the things we talk about is we have design projects now every, you know, starting with the sophomore level, we have a sophomore design project, junior design project, and now senior design project has been there for quite some time. And so that's all with the goal of giving our students lots of hands-on experiences to be prepared for a career at the moment they, you know, start working somewhere. And so these all just kind of flip through things about UTA. It's one of the top 100 electrical engineering programs in the country. Best value college. I'll let you read through this. I'm not going to spend a lot of time on this, but Shannon is one of our graduates as well, right? So we're proud of Shannon, and we're glad to still have that interaction with him. So throughout our career, we have this threaded curriculum that basically through about the junior year, it's talking about things we feel all electrical engineers need to know, but then moving partly in the junior year, but moving into the senior year, we allow students to select different types of courses so they can focus in like power and energy, electronics and photonics, control systems. Controls has a lot of applications, especially when you combine machine intelligence and so forth into that, working with drones and flight controls and all that sort of thing. Communications and signal processing. This is kind of where Internet of Things fits, as well as computers and digital circuits. This gives an idea of where some of our strengths are in terms of research, for example. So we have a number of faculty working in photonics. Okay, so one of the simplest examples of something that's photonic is a fiber optic cable, for example. Okay, it doesn't conduct electrons, but it does carry photons of energy. So circuits that work on that principle are called photonic circuits. We have faculty that do work on energy storage related to, you know, large batteries for not only hybrid or not only electric vehicles, but also, you know, being proposed for like electric battleships and so forth. Communications, there's your Internet of Things, remote sensing, you can see all these different things. So we have faculty working in all these different areas. And for students who come to the department, there are opportunities to work as an undergraduate researcher in some of these labs. That depends on, you know, making agreements with the different faculty members and so forth, according to what they have available. Okay, this just points out a few of our faculty being recognized. Lung cancer screening from exhaled breath is one application that our one faculty member is looking at using optical techniques. We had another faculty member sitting on a national panel looking at the power grid problem we had last February with the big freeze we had. And in terms of robotics and controls, the National Science Foundation publicizes some videos about one of our faculty members who works in the area of supporting emergency response and disaster relief using drones. So this is just talking about complex design problems. There are a lot of steps to it. I'm not going to try to go through that here, but and Shannon can do, you know, he can do a great job with this kind of stuff, right? So, but at any rate, it's important to understand the complexity of a lot of these types of problems. And, you know, so in our junior, sophomore, junior, senior design courses, we try to get get our students past the point of just thinking that it's good enough to get something working. That's not at all good enough, right? So you have your customer, whoever that is, defines the specifications, and these specifications usually tie to things having to work in extreme conditions or be very reliable, whatever the case might be. But there's a whole lot of things involved here. You can go from small scale individual companies to, Lockheed Martins and Bells and so forth. We have a lot of subcontractors to build their systems. But at any rate, it becomes very complex in a hurry. And I think the purpose of this slide is mainly just to indicate it for students who do think about coming to UTA. We do have scholarship money available, both through the university and a smaller amount through the department as well. Let's see, just some of the things that we do have some pretty nice maker spaces. We are offering tours. I don't know if I have the link to the tour here today. I think there's a QR code. Maybe that'll let you get to the, if you're interested in a tour of our labs, we're glad to give you some. If this QR code works for you, use it to sign up for one if you're interested. Or you can contact us. You can contact me or go to the EE website and look under our lab capabilities, and we can help you sign up for one of our tours. We're usually giving them a monthly, although we're working with some school districts as well to have designated tours for classes and that sort of thing. But at any rate, our lab technicians are also great in terms of providing workshops for training using equipment, doing PCB layouts, manufacturing, soldering, and so on. I'm offering a workshop next week. I'll put a little plug in for that for RF. We're working on getting more students engaged in the RF area. And so I'm doing that this coming weekend. And so there's the monthly tours thing. I got a little ahead of myself, but nonetheless, like I said, we welcome you to sign up for that if that's something you might be interested in. And Todd Kelly's YouTube channel. Okay, here you go. He's our lead technician for our undergraduate labs. And so check it out, find out what he's up to, what we're up to in the teaching labs. And so just talking about a lot of the companies, not only in the area, we have graduates who are nationwide at some of the largest, best known companies out there. So, internships are out there as well. Let's see, starting salaries, range, a lot of student involvement. It'd be nice if we had a student presenter here today, but we don't. But, we can, if we have some follow-on activities, certainly we can get more students involved in presentations down the road. Here's one talking about our Autonobots group. This is a club that we have in the department. Actually, it's not limited to our department, but it's kind of hosted through the EE department. But it's talking about all kinds of autonomous type systems and vehicles that we're working with as a part of that club. A lot of the other organizations, IEEE, I think a lot of people are familiar with the main professional organization. We do have other organizations. HKN is the honor society, essentially professional society of the department, as well as ones like Hispanic engineers, Asian engineers, Black engineers. And we also have one for women. I don't know why that's not here, called SWE. Let's see. Oh, here's the women's initiative. I guess Diana put a separate slide together on that one. So we do have a Women of Electrical Engineering group. If anyone's interested in learning more about that, that's where we'd be nice if Diana was here, but she couldn't be today. So let's see. Anyway, this is just information about applying, thinking about applying if you're interested. So let's see. That's a quick run through. Any questions? Anything I can address? We're excited to be a part of the solar car competition, and I enjoyed seeing what part of Shannon's presentation that I was just in on. And so if there's any way we can connect to that, we'd be glad to talk about that.
Thanks, Professor. I'll open it up for any questions that anyone has for the Professor. But we just thank you so much for the support that your school and your department has provided to us. And we think that, the next step after you finish solar car, when you think about careers, certainly electrical engineering is on the map of, you finish the complex system of a solar car, now you can expand to complex other systems within electrical engineering. Thank you so much for your time, Professor, and just appreciate your presentation, and we look forward to working more with you guys.
Okay. And yeah, I'd like to say thanks to Shannon too. He helped draw us into this. Layman has been very supportive. And so we're, again, excited. As we go farther down the road, we're interested to find out what else we can be involved with this group.